Welcome friends. In this tutorial, we will learn about binary tree data structures and types of binary trees. Now what is a binary tree? A binary tree T is a finite set of nodes with one of the following properties. A. T is a tree if the set of nodes is empty. B. The set consists of a root R and exactly two distinct binary trees, the left subtree TL and the right subtree TR. The nodes in T consist of node R and all the nodes in TL and TR. Here we can see a diagram of binary tree. Strictly binary trees. If every non-leaf node in a binary tree has non-empty left and right subtrees, the tree is called a strictly binary tree. A strictly binary tree with n leaves always contains 2n-1 nodes. A complete binary tree. A complete binary tree of depth d is the binary tree of depth d that contains exactly two nodes at each level between 0 and d. The total number of nodes equal to the sum of number of nodes at each level between 0 and d, which is equal to 2 raised to d plus 1 minus 1. This diagram shows a complete binary tree. Almost complete binary tree. A binary tree of depth d is an almost complete binary tree if number 1. A node nd at level less than d minus 1 has two sons. Number 2. For any node nd in the tree with a right descendant at level d, nd must have a left son and every left descendant of nd is either a leaf at level d or has two sons. Now let us see the binary tree traversals. A traversal is where each node in a tree is visited and visited only once. For a tree of n nodes, there are n factorial traversals. Of course, most of those are hard to program. There are two very common traversals, breadth first and depth first. Breadth first traversal. In a breadth first traversal, all of the nodes on a given level are visited and then all of the nodes on the next level are visited, usually in a left to right fashion, and this is implemented with a queue. Depth first traversal. In a depth first traversal, all the nodes on a branch are visited before any others are visited. There are three common depth first traversals: in-order traversal, pre-order traversal and post-order traversal. Each type has its use and specific application. Now, traversing a binary tree. Consider a binary tree as shown. For pre-order, number 1, visit the root. Number 2, traverse the left subtree in pre-order. Number 3, traverse the right subtree in pre-order. Here the pre-order is A, B, D, G, C, E, H, I, F. Now the in-order traversal. Number 1, traverse the left subtree in in-order. Number 2, visit the root. Number 3, traverse the right subtree in in-order. The in-order traversal of this tree is D, G, B, A, H, E, I, C, F. Now the post-order traversal. Number 1, traverse the left subtree in post-order. Number 2, traverse the right subtree in post-order. Number 3, visit the root. The post-order traversal for this tree is G, D, B, H, I, E, F, C, A. These are the steps involved in in-order, pre-order and post-order traversal, which are similar as we had seen in the previous example. These are recursive steps. Thank you for watching this tutorial. In the next tutorial, we will talk about binary search trees and its operations.